This conference will now be recorded.
Good afternoon, one and all. This is Rajesh. In our subject Embedded System Design, for our second unit, we will discuss about sensors and actuators. So you can see these are the topics of second unit. Unit 2 is typical embedded system, in which first is objectives, introduction, core of the embedded system, general purpose and domain specific processors, ASICs, PLDs, commercial off-the-shelf components. Under memory, it is ROM, RAM, memory according to the type of interface, memory shadowing, and memory selection for embedded systems. See, our topic is sensors and actuators. So communication interface is onboard and external. See, and the textbook is Introduction to Embedded System by Shibu KB. So the topics, the objectives of this unit are elements of embedded system, how embedded system works, differentiating between microprocessor and microcontroller, and classification of the processor based upon the architecture, based upon Indianness, based on the bus. So based on the bus, there is one classification like Harvard architecture and von Neumann architecture. Based upon the instruction set, it is RISC and CISC architecture. Based on the Indianness, it is little Indianness and big Indianness. So then we are going to see the overview of the process from simple to the complex. And our topic today is sensors and actuators and communication interfaces. So from the previous study, we have seen that what is the embedded system, what are the elements of embedded system, and you know that embedded system is part of your life. All the products which you are using, they are related to embedded technology without our knowledge. Our household appliances, refrigerator, washing machine, air conditioner, television, DVD players, museum systems, they all are coming under embedded systems. They are all built around an embedded system. So what is an embedded system? Embedded system is a unique system. Its hardware and software are highly specialized to the application domain. So if you see our intelligent vehicle automation, car automation, there our embedded logic is available in headlamp controllers, engine controllers, ignition controllers, and to that of complex airbag control system. So all these require this embedded system logic so that you can initiate simultaneously, and hardware and software together indicate headlamps, engine controlling, ignition controlling, as well as airbag. And there is a priority assigned to one of the systems. So embedded system is a single system, or it can be a part of a big system. And these embedded systems are available as an inevitable product in all the fields such as household appliances, telecommunications, medical equipment, industrial control, consumer products. So these are the areas where we are seeing these embedded system products. So our definition is embedded system is defined as an electromechanical system designed to perform a specific function, and it is a combination of hardware and software. If you see, our microprocessor is controlling an automobile engine, it comes under an embedded system. These embedded systems are designed such that they run on own, and they do not require human intervention, and they receive inputs in real time. So these are the examples of certain embedded systems like a traffic light controller, smartphones, switches, DVD players, washing machine, refrigerator. So an embedded system can be thought of as a computer hardware having software embedded in it. An embedded system can be an independent system, or it can be part of a big system. So another definition you can give for an embedded system is microcontroller or microprocessor based system, which is designed to perform a specific task. Like your fire alarm, this is an embedded system which is sensing the smoke, and you cannot use this embedded system for another system because the control unit designed for fire alarm is different from that of an air conditioner. So under elements of embedded system, you have seen the embedded system is a combination of three things. It has an hardware, it has a software, it has a mechanical components. Your embedded system is a reactive system. It gets input through the sensors which are connected to the input ports, and the common user interface input devices are keyboards, push buttons, and switches. And this embedded system main part is called a system core. This system core is connected to the input ports, to which we have connected sensors. To the system core, at the output we have connected output ports, to which we have connected actuators. Then there is a memory, there is a data exchange between system core and memory. So your memory consists of the control algorithm, how an embedded system will perform its logic, how its behavior is written in the ROM, read-only memory, by the manufacturer. So this is unique for all the systems. So you can see here a system core, input ports, output ports, all peripherals are connected, and there's the memory is connected, and in the memory we have stored the embedded firmware. So there is a microcontroller with the on-chip ROM called Atmel 89C51. So coming to core of embedded system, the core of the embedded system is a hardware processor. It can be a general purpose and domain specific processor such as microprocessor, microcontroller, and digital signal processor. So you can use either microprocessor, microcontroller, or DSP, or you can use an application specific integrated circuit, or you can use a programmable logic device, or it can be a commercial off-the-shelf component. If you go for a general purpose domain specific processor, you can use a microprocessor or a microcontroller or a DSP. So we have also compared in our previous slide what is the difference between microprocessor and microcontroller, and what a DSP does, and what a RISC and a CISC architecture is. And based upon the architecture side, if you see, your microprocessor can be a RISC architecture or a CISC architecture. Your microprocessor can be a hardware architecture or von Neumann architecture. If you go for bus sharing, it can be a hardware architecture or von Neumann architecture. So again, if you go for the data, how a byte is stored in the memory, you can differentiate them as a little endianness and big endianness. So if a ready-made processor it is used, it is a general purpose or domain specific, that comes under a microprocessor, microcontroller, or a DSP. Or if you go for a processor which is to be designed by the manufacturer, that comes under as ASICs, application specific integrated circuit. And the next is programmable logic device. So you can use a ready-made programmable logic. It can be a ROM, read-only memory, or it can be a PLA, or it can be a PAL. So PLD means programmable logic device. If you go for simple PLDs to complex PLDs, the number of amount of logic gates will be 1000 gates. If you go for an FPGA as your hardware core, it consists of a different logic. This is the logic for a CPLD. All the PLDs are connected by interconnect wires, which are connected to the output or input pins through IO blocks. If you see this FPGA architecture, the design is available as a configurable logic block, which are connected by switch matrix through an IOB input output blocks. These CLBs are connected to the external pins, and you can configure the external pins to act as either input and output. So coming to next is ROM, PAL, and PLA, which we have covered in our previous classes. So there can be a commercial off-the-shelf component. Means there is a ready-made design which you can directly insert and you can use it as a hardware core. So coming to memory, memories are of different types, RAM and ROM. Under RAM we have seen static RAM and dynamic RAM. Under ROM we have seen PROM, EPROM, EEPROM, and flash memory. So these memories can be used for saving the permanent data as well as temporary data. So coming to our topic today, we have to discuss sensors and actuators. So this is our topic called sensors and actuators. A sensor is used for taking the input. It is a transducer that converts energy from one form to another form for any measurement or control purpose, such as temperature sensor. So this temperature sensor will sense the temperature of the room, and it will convert into an analog signal. So if you see the actuator is used for the output. It is a transducer that may be either mechanical or electrical, which converts signals to the corresponding physical actions. So that is under which we have LED. So our embedded systems have to interact with the real world through either any sensors or actuators. So this controlling or monitoring function is extended because the changes in the real world must be detected, and these changes in the environment variable must be detected, and corresponding output must be generated and given to the output ports. and for which we are using the sensors and actuators. Under sensor, if you see, it is a transducer device which converts energy from one form to another for measurement or control purpose. It is an input device. So if you see the Hall effect sensor, it measures the distance between cushion and magnet in the smart running shoes from Adidas. So other examples of sensors are IR sensor, humidity sensor, passive infrared sensor, ultrasonic sensor, piezoelectric sensor, and the smoke sensor. So this diagram shows a soil moisture sensor which detects the soil moisture content. Next is the infrared sensor. Next is the ultrasonic sensor. Similarly, there is an actuator. It is an output device. This actuator is a transducer device. It can be a mechanical or electrical one, which converts signals to physical motions. So these are some input output devices like webcam, monitor, printer, headphone, speakers, printer. Okay. So and this diagram shows an Arduino board where there is an LED, there is a relay, there is a LDR, light detecting resistor, and there is a temperature sensor, and there is an infrared sensor, there is a buzzer, there is a potentiometer, and there is a push buttons. So these all are placed on the green color PCB Arduino board, and this may act as input output devices. So coming to our input output system, the input output subsystem of the embedded system facilitates interaction with the embedded system with the external world. So if the embedded system want to interact with the external world, it has to do through an input output systems, and that interaction happens through sensors and actuators connected to the input output ports. The sensors may not directly interface to the input, but they may be connected through some signal conditioning and translating systems like ADC and optocouplers. So if you see the first input output device, it is an LED. LED stands for light emitting diode. LED is an output device for visual indication, and this for status of signals, and such as device on, battery low, charging of a battery. So such indications will be done by an LED. LED is normal PN junction diode where anode is connected to VCC, cathode is connected to ground. So for proper functioning, what we do, we will allow exact current to flow through this LED below the maximum value, and a resistor is used in between the power and the ground to limit the current. So depending on the current flowing, this LED will glow. Similarly, you can use a 7-segment LED display where you can display alphanumeric characters. It is an output device. So this numbers 0 to 9 or any character can be displayed on a 8 light emitting diode segments arranged in a special form where these LED segments are named as A to G and the decimal point is named as DP, and this configuration is available in two types: common anode and common cathode. If you see the common anode, all the anode pins are tied together. In common cathode, all the cathode pins are tied together. Here the current limit is 20 milliamperes. That is one output device. So there is one more output device called optocoupler. It is a solid state device. It is going to isolate two portions of a circuit. The left portion consists of an LED. The right portion consists of a phototransistor. They are kept in a package. The main purpose of optocoupler is it is for suppressing the interference in data communication, circuit isolation, high voltage separation, simultaneous separation, intensification cell. So these optocouplers are used as either input circuits or output circuits. So if your port pin of a microcontroller is connected to phototransistor, the input coming from the interface is passed to the LED. LED generates a specific light which falls on the phototransistor, and it generates a specific voltage which is sent to the port pin, like which the input interface is connected to the port pin and the port pin is connected to the output interface in a similar fashion. And the next input output device is a stepper motor. A stepper motor is an electromechanical device which generates a discrete displacement. If you apply a DC voltage, it does a rotation in discrete fashion compared to normal motors. And this stepper motor is available in two forms: two-phase, and this two-phase stepper motor is classified into two types: unipolar and bipolar. What is unipolar means? If the motor windings, if per coil, okay, the contains two windings per phase, that is called unipolar. If it is consisting single winding per phase, it is called bipolar, and based upon the rotation of the direction of the current, rotation anti-clockwise or clockwise will take place. And the next IO subsystem is a relay. A relay provides a dynamic selector for signal and power. Relay is consisting of a coil made up of an insulated wire on a metal core and a metal armature with one or more contacts. It works on the principle of electromagnetic principle. So this input-output system IO device relay is working on the principle called electromagnetic principle. When a voltage is applied to the relay coil, current flowing through this coil will generate a magnetic field. This magnetic field is attracting the armature core and moves the contact. So when a voltage is applied to the relay coil, current flows through the coil, which in turn generates a magnetic field. The magnetic field attracts the armature core and moves the contact point. The movement of the contact point changes the power signal flow path. The relay is normally available in two forms. The relay is normally controlled using a relay driver circuit. So there is a relay driver circuit which is controlling the relay connected to the port pin of the processor. A transistor can be used to act as a relay driver. The transistor can be selected depending on the relay driving current requirements. So your transistor is selected depending on the delay driving current requirements. So if you see, this is the relay available in two forms: single pole, single throw, normally open. So once current flows through the coil, there is the single pole, single throw, normally closed. Next is the single pole, double throw. So, and the next IO subsystem is a piezo buzzer. The piezo buzzer purpose is it generates audio indications. So whenever a specific amount of current flows through this piezo buzzer, the piezoelectric diaphragm produces an audible sound in response to the voltage. There are two types: self-driving and external driving. So this piezo buzzer will generate an audio sound based upon the voltage applied to a piezo diaphragm. And these piezoelectric buzzers are available in two forms: self-driving and external driving. Self-driving means they generate a predefined note. External driving means they generate tones of different tones. They generate different tones, and this different tones can be generated by applying a variable pulse train to the piezoelectric buzzer. And this a piezo buzzer can be directly interfaced to the port pin of your microcontroller. And the last IO subsystem is a push button switch. It is an input device. If you push to make, push to break, these are the two configurations of push buttons. A push button is available as a push to make or push to break. The switch is normally in the open state, and once it makes a contact, it is called push to make, or normally it is closed, and it can be pushed to break the contact. That is called push to break. Normally closed, once you press the button, it becomes push to break. So this, you can see the port pin is connected to VCC through this push button and connected to ground. Once you push it, a specific voltage is applied to the port pin. So this is a high push button, and port pin is connected to the ground through a push button. Once you push it, a low voltage will be applied. So these are the 7 input-output devices which we have come across. The first one is the IO system, LED, light emitting diode, and the second one is 7-segment LED display, and the third one is an optocoupler, and the fourth one is a stepper motor, and the fifth one is a relay, and the sixth one is a piezo buzzer, and the seventh one is a push button. So these are the sensors and actuator topic, under which we are studying that your microprocessor, the main hardware core is connected to the input ports, and to which we are connecting the sensors, and the same system core is connected to the output ports, and to which we are connecting an actuator, and the actuator is going to give a physical action based upon the electrical signal generated. So sensors and actuators are main core part. If you see any example like your washing machine main purpose is to wash the clothes. It takes a specific quantity of clothes and washing powder, then it takes the water and it washes the clothes for certain time, but the indication is a display unit. And the display we will select the on button. So then after washing, it will indicate that the clothes are washed and dried. Similarly, if you take the car automation system, the car automation system is consisting of various sensors. Whenever there is an obstacle approaching near, whenever there is a wall, when you are taking the diversions, it will just give an alarm or buzzer sound that some obstacle is available. In all the vehicle systems, flight control systems, radar systems, we have sensors. The sensor purpose is depending on the design, like some sensors will detect the humidity, some sensors will detect the infrared, by they send an infrared signals, and they will detect the obstacle like in radar systems. So if you consider our next example like air conditioner system, the air conditioner system main purpose is to give a cooling to the room, and the what the user does is he indicates the temperature he wants to make the room cool by on a remote. And the once you switch on the power of air conditioner, it detects the room temperature, and if it is 38 degrees, it will display the 38 degrees uh, uh, in its internal logic, and whatever the temperature you set, that is displayed on the AC. And in order to achieve that temperature, it will take the difference of the temperature of the room and the temperature set by the user, and this data is sent to, as a control signal to your actuator. The actuator will run the output motors, due to which the air flows into the uh, design, air flows into the room, and like that cooling occurs. Once it room attains the exact temperature, um, uh, the motors automatically get switch off, because there is the control signal is stopped from the processor. So the processor logic, the control element logic is they just take the difference of the temperatures, room temperature and the temperature set by the user, and they just generate an signal to be sent to the actuator. That actuator will run the motor fast or slow such that cooling is given to the room. So here we are using an actuator as well as sensors, and like in one more applications, like in robotics, in industrial control applications, where different color bobbins will cable, like any cable, if it is manufactured, cable will be indicated with different colors. So they are winded on a bobbins. So the robot will identify based upon the sensing the color, and then it will lift that bobbin and it will place in an exact place. So there also we are using sensors, and in order to detect the soil moisture, we are using sensors. So like that sensors are used in various applications, and all sensors and actuators are connected to the embedded system. So the core part, the peripherals of your embedded system are the sensors and actuators, and the control algorithm is stored in the memory. See this then one more topic called the communication interfaces. Like we told, the hardware core, memory, input output devices on the board are connected. So they are connected on the board either wired method or wireless method. So if it is on board, we can use the integrated inter-integrated circuit serial peripheral interface, UART, one wire, parallel wire. So these are onboard communication interfaces. So second one is external communication interfaces. So external communication interfaces are the embedded system has to interact with a system placed at some other place, either wired method or wireless, for which wireless techniques are infrared, Bluetooth, wireless LAN, radio frequency, GPRS. So using an infrared technique, you can use wireless transmission, Bluetooth, a wireless transmission, wireless LAN, Wi-Fi, radio frequency waves, GPRS. Next, they can also be connected. So your embedded system can be connected to an output device through an RS-232 port or a USB, Ethernet, IEEE 1394 port, parallel port. So all the devices onboard or outboard are connected through these interfaces, and this communication interfaces will cover in another topic. So the main core part of your this unit is sensors and actuators. So just we'll go through again once again. The input output devices are LED, light emitting diode. It is an output device for visual indication in any embedded system. So LED is an output device based upon the specific current flowing through the anode to cathode. The LED will glow. It is used for visual indication of certain status signals. Similarly, there is a 7-segment LED display. This LED displays numbers and alphanumeric characters, and they are arranged in a specific fashion from A to G as well as DP. And they are connected in two methods: common anode method, common cathode method. Next is optocoupler. This is a solid state device where your phototransistor and LED are connected. And similarly, we are having a stepper motor. Similarly, we are having a relay. Similarly, we are having a piezo buzzer. Similarly, having a push button. So with this, we'll stop our discussion. Thank you.